Hello everyone, it is December 2nd, 2025, and this is the libhal bi-weekly meeting. All right, for the agenda today, we actually skipped last weekend, and I don't remember, or last week, I don't remember if we skipped the week before that, but for the most part, we're back. We have a couple things to talk about. I've been doing a lot of work on mostly continuous integration and adding in more tool chains. This is always the thing that I wanted to do because I knew it would make my life a lot easier, and eventually it became something that I needed to work on, primarily because libhal v5 is moving to modules, and LLVM supports them way better than GCC. But yeah, so for the agenda today, we're going to go over conan-config 2. I'm going to talk about what's in there and how it's going to decrease the number of steps we do for setup, as well as the conan command and where it's at now. I'm also going to talk about some improvements to the continuous integration that I've made, as well as talking about the new llvm-toolchain. I'm excited to have that, honestly. I'm just so happy to have it around. Oh, and actually there's a little mistake here. We're not talking about coroutines this time. I thought about putting it in, but there's not much to discuss yet. I want to make a little bit more progress before I go and talk about these. But I will talk about v5 modules progress. All right, first, conan-config 2. This slide's a bit busy, but basically this repo has this structure. A couple of these things don't matter too much, like settings user.yaml. Here we can see the hal command. This particular repository has the hal command within it. It also has a bunch of profiles. It has all of the profiles that libhal will work with for whatever. The idea here is if I structure this directory in the same layout as the conan home address, you can do conan config install, then you just put in the link to this GitHub, and it'll clone all of the files into the conan home directory. This will do a couple things for you. It'll install the conan-hal extension command. It'll provide all of the libhal user settings, which defines the architectures that we support. So Cortex M, 1, 2, 3, whatever, all those things do not exist inside of the conan settings, global settings. So in order for us to build software for those things, we need to make up those settings. And then finally, we have all of the profiles for libhal. So I've actually broken it up into a couple of directories. I hope this is a sane way of doing it. We have BSP, which is our board support libraries, like Micromod. We have MCU, which are our microcontrollers. We have operating systems, which is our available operating systems, like Linux, Mac, and Windows for ARM, x86, 64. And then finally, we have our tool chains. So this will be GCC and LLVM. I have a desire to get rid of the solo ARM GCC tool chain. It's kind of fine, but I think it's just it would be better off if we just said GCC. Rather than saying ARM GCC, we said GCC. And if you're running a program on your Linux machine natively, then it'll just use the GCC for your machine. If you're running, same thing with Mac, same thing with Windows, if you're cross-compiling, then it should download and install the cross-compiler for that use case. If we support it, if we don't support it, then we error out on you. And if that's something that you really want, make a comment on the appropriate GNU toolchain repository, and we can add in that support. Yeah. Oh, and if you ever do ask, if anyone ever sees this video and asks that question, please provide a link to where the pre-built binaries are. And if you want to be even better, if you can also honestly, if you make the PR just to add in the Conan data files in order to make those available, that'd be really great. But otherwise, just pointing us to where those binaries can be found would be fantastic. All right, with conan-config 2, there's even less steps for setup. This is gonna be it. There's 3 steps, technically 4 when you actually go to build, but when it comes to setup, it should just be pipx install conan. Then you're gonna do conan config install, and you're gonna put it into libhal config 2. And then when you're done with that, you do conan-hal setup, and this will install the conan remote. And to be added, we're also going to auto-detect your operating system and your architecture. That's necessary for Conan to be able to do anything. It needs to know at least what it's working on in order to figure out what binaries to use and that kind of thing. So it'll do all that stuff for you. And then after you're done with that, after those 3 steps, you should be able to just do conan build app. And then because we have that directory structure, we now have hal/mcu/lpc4078 and so on and so forth. I have some ideas. Actually, I haven't written this down yet, but I had an idea sometime like a week ago to add in a way to make aliases for these. I thought we could use the alias keyword in Mac and Linux, but it turns out that that only works for commands. I thought that was the case, but I also got kind of confused. But yeah, some way to easily like truncate these down, I think would be great. But also, if a user really wants to have a shortened version of these things, they can also just create their own profile and add a include block for this, and they don't have to type it anymore. They just type in -pr, whatever the name of your profile is going to be. Yeah, I'm pretty happy with this. Once I get the last detection part added in, this will be the only steps you need in order to set up libhal, and I think that'll just be a very smooth and frictionless setup, especially because this should always happen so long as you have internet. This should work so long as GitHub is up. This last part is the part that could fail, but there's only a few things it has to do, so I don't expect that to fail. All right. CI improvements. Probably doesn't matter for anyone. This is actually more of something that I just want to document. I've added 3 new actions: app builder 2, package and upload all. I'll go into those in a little bit. But before I get into the simplified stuff, I'm just going to say that there were quite a few different actions that I realized were redundant, doing the same thing. Let's just say R here for builder. But the idea here is that app builder was supposed to build applications. Demo builder was supposed to build demos like we do for most things, except this was too specific, and this one just was missing features. So I kind of combined them together to create app builder 2. Also, these new actions all take advantage of the Conan config 2. So when you specify what profile you want, it's with respect to the Conan config 2. This makes it a lot easier for what we're doing and for what anyone else who's writing programs and applications using libhal would want. But if there's a desire to have something that's a little bit more free, less built for the purposes of libhal, you can reach out, but most likely you can just copy this and then add what you need. We also had separate deploys for Linux, Mac. This is just for general, and then for everything. And the everything was actually mostly just for Cortex-M, which I even thought about replacing this from all to ARM, or ARM Cortex. At the end of the day, I realized that with the new Conan config 2 directory, and with the, which I'll talk about later, the llvm-toolchain, with both of those things embedded, actually, let me check real quick. Yeah, okay. Both of those things added to the project made building package and upload all very simple. Because the steps are just this. There's no longer any, that's probably my favorite part. I was able to get rid of all of the OS specific operations, like downloading the llvm install script and then running that. It's mostly the same between Linux and Mac, but I get rid of all those because that's not necessary anymore. With the llvm toolchain that we have now, we just do this, build this, and everything else just happens for you. So now that we have this, I was able to get rid of all of the platform-specific stuff out of all of them. So now we just have package and upload all. These will all give like a little bit of a deprecation title now. I am planning on slowly moving everything over to the new package and upload. Deploy Linux probably won't get any love just because the libhal Linux hasn't gotten any love in a while. But at some point, we'll be able to easily do this. Oh, and last thing before I leave, package and upload all also pre-builds your binaries for Linux, ARM, Linux x86, Mac, Windows, same set of architectures except for ARM Windows. Oh, and I guess not Windows in general, just because Windows seems to be segfaulting. But I'm gonna start experimenting with building for Linux and building for Mac, so that when users go to use our stuff, that stuff's actually there and available for them, and see if there's any issues. All right, so the conan-hal-command officially from the config 2 has setup and update commands. I already talked about what setup does. Update will pull the latest Conan config 2 to your local machine. But if there's a specific version you want, you can do --tag in order to access that. Future commands that I know that I want, I just have to come up with a good way to make them work, is conan flash and conan debug. You give it the profile that you want to program over without the compiler, and it will, you can add the compiler if you want. It'll ignore it, but you just add that information and it should be able to figure out using your platform ID how to flash your device. Same thing with debug. That would be the plan for both of these. I'll probably use PyOCD for this as well when possible. My only concern is you need PyOCD installed at first. So I might do a thing where I check to see if you have PyOCD running. If it's not or installed, then I'll tell you to install it in some way. But then shouldn't we do a virtual environment? So I have ideas of how to do all these. All these are Python scripts I have to pull in, and that's the part that's kind of hanging me up right now. All right, I've been talking about this a lot, but finally able to really just kind of talk about it. The llvm-toolchain host and ARM support. You know, I should really put my face down here. I know there's a way to support that. I'll do that later, some other time. So yeah, llvm-toolchain host and ARM support. You already kind of saw an example of this. If you wanted to build something, you do hal mcu stm32f103c8, and then you can do -pr hal tc llvm. This last bit here doesn't actually work yet. You still have to specify -19.1.5. I am working on what's the good happy median of most up-to-date LLVM that also supports most of our platforms. The cool thing about this is that it's a single tool package to install the appropriate precompiled binaries based on your profile information. So if you're going to build LLVM and you're going to try to target STM32F103C8, it's going to need to get the official LLVM pre-builts from ARM. We don't have to get them from ARM, but the benefit is that they actually pre-build in picolibc and a couple other really useful things. So they actually designed that version, the LLVM toolchain, to be nice to use, very nice to use. It's actually, they even show like, here's a single command that you can run to just kind of get something going, and then you can simulate it. And I think that's like just amazing. So they did a good job on llvm toolchain. I did find it kind of annoying because I had to learn how to extract files out of a DMG file because that's all they provide. But it does all that. It'll download the DMG, then it'll mount it to a directory, usually the build directory for your package, and then it'll extract the files into the package directory, and then now you have your compiler available. This depends on the version, but between all the versions, we pretty much have Mac support and x86 support. Actually, I should probably remove this. x86 64 support for Mac is pretty much going away. So we're probably not going to have this anymore. And there's only like one thing I think I have that supports this, so I should probably remove this. Windows, we can install and build, but the programs, not all of them to default, but some of them do, so we got to figure out why that is. And then for Linux, we have ARM and x86 support. We'll have both of those for a while. If you've noticed, I've been saying LLVM without a version tag or version suffix. And what it basically means is the latest version of LLVM that has all pre-built for it. And this just means that like if there was going to be if we're going to support RISC-V, Mac, Windows, Linux, and so on and so forth, we would choose a version of LLVM that like fits all of those things. Hopefully, it doesn't hold us back too much. I will definitely drop a platform if it's too behind, or I'll figure out how to make LLVM work well with that platform without needing their pre-builts to be already. But yeah, so that's kind of the game plan here. I plan to keep this quite up to date with somewhat feature parity with GCC and just enough to make sure that all of our projects build. Although we will kind of get over that for now just because GCC doesn't have good module support, which we'll talk about in a sec. But I plan to keep LLVM updated often. I want to break this idea, this cycle in C++ that you pick a compiler and then you stick with it forever. No, what we're going to do is we're going to keep up to date, and the goal is that people continually update their stuff. And if they try to build and stuff doesn't work, we tell them, hey, did you upgrade? And they're like, no, then you should upgrade. Because that's how things work with everywhere else. And I think there's a lot of great improvements that are added into the compilers, and I think what people just need is a way to easily upgrade. So yeah. Now on to module support, which will be the last thing we'll be talking about. I have finally reached the end of where LLVM continues to work and GCC begins failing. I wanted to see how far I could go before that became a problem. I was working on strong pointer and getting that to be properly modularized so that I could ship that as a binary and then ingest it into async context. And I'll show what that diagram looks like in a bit. But basically, once I had like multiple levels of like dependency, it seems that GCC just starts messing up, and I get these like bad file data, modular cluster errors. Seems to be due to the including the chrono library or other things, but yeah, it just seems to be upset. So kind of showing what some of the dependencies look like. Strong pointer is actually going to be the basis of, I think, almost all of our libraries, except for like the ones that we pull in that are third party. Strong pointer goes into async context. I'll talk about more about why that is later on, but basically I'm getting rid of callback functions, or at least we're not going to use standard function, and we're not going to use in place function, and we're definitely not using standard function. We're just going to, all I really need is an interface for what is basically a scheduler. So we're going to use strong pointer to make sure that the context, the async context, preserves the lifetime of the strong pointer that it has up until the point where it goes away. Exceptions may use strong pointer, maybe, may not actually. It depends on what happens. But I put this link here just because it might actually end up depending on it. And the MP units will also be a dependency here. So once I start building out HAL, I'm curious to see how well LLVM supports it. Oops, daisy. My guess is that it's going to work well. It seems they've had support for modules for a bit, and it seems quite mature. So if that works with HAL, then the next step is just to really start moving everything else over and seeing where things eventually break. And if nothing breaks, then we're in a good spot. And yeah, one last thing I want to say, which is I'm really happy today that I was able to get. I think I spent, just today working on adding in support for the ARM Cortex line of microcontrollers and architectures for LLVM to work. So I can actually build Blinker, and I actually built the ADC program. I'm going to test the I2C demo as well for libhal ARM MCU, but I'm pretty certain that it's going to work for all of them. The only thing that's kind of a bit of an annoyance is that I need to go through and find the parts in the exception runtime that are bloaty and remove them. I already got rid of the majority of it by getting rid of the mangle API, which turns your mangled names into expanded proper names. That library was eating up at least 40 to 60 kilobytes worth of memory, which didn't allow me to put it into the STM. But once I got rid of that, I was able to fit all the projects into the STM. So yeah, I'm excited. I'm so happy that it's working out because potentially for V5, we're probably going to just stick with LLVM up until GCC catches up. And I'm just excited about having more options for libhal, and the fact that these libraries can be used for anything. If you want to use llvm-toolchain for your own projects and other stuff like that outside of libhal, you can definitely do that. It has its own set of Conan profiles as well, so you can just use it and it'll just work. So I'm just happy to have this thing available now, just because it's been so painful having to keep instructions for every single platform and making sure that they're always up to date and all of that. I don't care. I don't want to deal with that anymore. I just want to just simply use the tool. It downloads the stuff for me, puts it in the right spot. Everything knows where everything is supposed to be, and it just works. And we're there, at least with LLVM. At least I need to clean it up to get to finish up. But yeah, that's pretty much it. I will hopefully talk to you guys in the next 2 weeks with some really awesome updates on how things are going.